welcome back to the tutorial number 9. In tutorial number 9, we will be discussing problems on magnetic potentials. Before starting any problem on this one, let's take a quick look about the key expressions. The first expression is del cross A is equal to B. The first expression will be del cross A is equal to B, and the second expression will be, that del cross H is equal to J, right? And integral of B dot ds is equal to 5. So we will deal with these three questions in this particular tutorial. So the first problem states that there is a current distribution giving rise to a vector magnetic potential. This is A, and we need to calculate H and also flux through the surface. Right. So A has been given for us. We need to determine H. So we will calculate B is equal to del cross A, and from that one H can be computed as B by mu. Right. This is one thing. Second thing is, to determine the flux, we can employ this particular formula, field intensity and also the flux. So let's start with the first one, where the magnetic potential has been given for us as A is equal to 15 e to the power of minus r sine phi uz, which means it is in z coordinate. So we do have three different sets of coordinate systems. See, since there is z, it can be in these two. Since it is phi and r, so it will be most probably this one, cylindrical system. So if I want to determine B, then it is del cross A, del operator, so dou by dou r into dou by dou z. So del coordinate systems, this is the del operator, right? So this one, it is there only in z coordinates, 15 e to the power of minus r sine phi, right? So this is del operator and this is A operator. So here these things, these are r, phi and z, right? So now what is this one? UR into 1 by r dou by dou phi of 15. So this is what your common term, this is B, right? So once you have obtained your value of B, the next thing is you need to determine H, right? H is equal to B by mu, and in this case mu is equal to mu naught into mu r. Mu r is 1 here, so mu naught is 4 pi into 10 to the power of minus 7. This is mu naught. Mu r, since there is no medium mentioned, I'll take it as 1. So this is 4 pi to 10 to the power of minus 7. So I'll take it as into cos phi by r ur bar plus sin phi u phi. This is my H. Okay. Now this one, I need to compute it H 3 comma pi by 4 comma minus 2. So this is r value, this is phi value, and this is z value. So if I substitute it, what I'll get? 15 e to the power of minus 3 by 4 pi into 10 to the power of minus 7 into cos pi by 4, it is 45 degrees, by r is 3, this is ur, this is 45 by 3, this is u phi. Sorry, I don't get by 3 here. Okay, sine 45. So sine cos 45 is 1 by root 2. Okay, this is 5 by 4 pi. You'll get somewhere around 14. I think 14,000 ur. So this will be 3 times, it will be 42,000 u phi. This is your H vector. at the point of 3 pi by 4 comma minus 10. So the first thing is completed. The second thing is determine the flux through the surface defined by this one. So we need to determine flux through that surface. See, we have already obtained B value. B is equal to 15 e to the power of minus r, right, into cos phi by r plus, so cos phi by r u r plus sin phi u phi, isn't it? Now I want flux, which is nothing but this is the flux expression. Now B I do have. Now ds is nothing but, see, it is in r phi z. R is constant, so I need to vary my surface in phi direction and also z direction, which means that if it is in phi direction it is r d phi, and if it is in z direction it is dz, and ur is constant. So what I'll get is integral of, this is 15 e to the power of minus r cos phi by r ur bar plus 15 e to the power of minus r sin phi u phi dot r d phi dz ur bar. So ur will get unity, whereas this will become 0, right? This is 0, this is 1. So what I'll get is, this is 15 e to the power of minus r by r. Okay, so r will get cancelled. So what I'll get is integral of surface, right? And this surface is, what is, phi is varying from 0 to pi by 2, and z is varying from 0 to 10. And it is 15 e to the power of minus r cos phi d phi dz. So 15 e to the power of minus r, it is not going to change with respect to any of these terms. So it will remain like this. Cos phi will become minus sin phi, whereas phi will be varying from 0 to pi by 2. Sorry, it is plus sin phi, right? And no value of z, so it will take it as z itself. So it will become 0 to 10. And here r is equal to 3 or 5, sorry, r is equal to 5. So if you substitute, you will get somewhere around 1.0 answer to your problem. Okay. Now we will move on to the question number 2, which states that vector potential is given by the following. A, you should determine the flux density. So very simple one. We know B is equal to del cross A. The only thing is that if you carefully see, this is in XYZ coordinate system. So ux, uy, uz. So del operator is dou by dou x, dou by dou y, and dou by dou z. And here only x component is present, and it is 72 by x square plus y square plus z square. 0, 0, isn't it? So if you do it, ux component, this is ux component 0 minus uy 0 minus dou by dou y of 7 plus uz component. uz component is, yeah, 1 minute, sorry, this is dou z, right? Yeah, this is 0 minus 72 by dou y of 0 minus 72 by x square plus y square plus z square, isn't it? So this will become 0, and this will become 72 by x square plus y square plus z square whole square, and this will become minus into minus is plus, this will become minus again, so minus 2, and here also this remains the same, but here you will get plus 2y uz bar. Okay, so this I'll take it as common, so this is my expression. Okay, so I'll write it again here. B is equal to 72 by x square plus y square plus z square whole square into 2y, so this is 2z uy bar minus 2y uz bar. Okay, so if I substitute the values of 1, 1 and 2, this will become 1 plus 1 plus 4 whole square into this will become 4 uy bar, and this will become 2 uz bar. So this is 6 square, 36, 36, 72. If you do it, you will get. So this is the way how we solve the problems. Okay, so hope you practice them at home. The unsolved problems in tutorial number 9, you practice them at home.